Okay, so the video is on some of the problems you did in class, but it's more for you to have something to go and check and, just in case you forget some of the procedures. So uh, I will do them. I don't know if I'm going to do all of them, but again, so I want you to create a habit of doing these steps because you're going to need them when we solve two-step equations um, and multi-step equations. So they're all the little steps that you're going to need to solve the bigger one. So again, um, I'm going to push you to do this. This is not part of your work, but it's part of it helps you sort of set up what kind of work you're going to do. Here's my variable m, and what's happening to it right now. The only thing that's happening to m is that it's 9's being added to it, and somehow it gives me 12. You and I know what the answer is, but that's not the point. So to solve this equation, I want you to use the inverse operation, right? And the inverse operation of adding 9 is subtracting 9. And that's going to give us our answer. So here's my equation. And I'm going to subtract 9 from both sides. So it's here's on the left side, I'm going to subtract 9. And on the right side, I'm going to subtract 9. So positive 9, negative 9. It's 0. I don't really need to write 0. So I'm going to just bring this m down here. And 12 minus 9 on this side is 3. So, like I said, we already knew it was 3, but this is the work I'm looking for. So your check is going to be, here's my original equation, m plus 9 equals 12, and we found out that the value of m is 3. Well, let's see if that makes that equation true, right? So 3 plus 9 is 12, and guess what? That does make my equation true, where the left side equals the right side. Okay. Let's work on the second one. Actually, I might do the whole thing. So 7 plus k equals negative 20. 7 plus k equals negative 24. So again, this doesn't. Here's my variable k. 7 is being added to it, and it's giving me negative 24. So I gotta find out what added to 7 is negative 24. So going backwards, I'm going to use the inverse operation of adding 7, which is subtracting 7. So let's show that. So now I'm showing my work, solving the problem. And it says that I want to take out 7 from this side, and I want to take out 7 from the other side. 7 minus 7 are opposites, right? So the additive inverse of 7 is minus 7, so these two become 0. K comes down. 24, negative 24 minus 27 is negative 31. So let's see if that indeed is true. So here's my original equation. Equals negative 24. So I'm going to write this, I'm going to write this, and I'm going to write this. So the only thing I'm removing here, I'm removing the letter k and replacing it with this, negative 31. So is 7 plus negative 31 negative 24? Yes, it is. So this whole thing I want to see. Next one. So again, here's my variable called a. We're adding 2.3. And then that's going to equals 9.72. Going backwards, I'm going to do minus 2.3 on both sides, and hopefully that'll give us an answer. So here's my equation. The left and the right side. I'm going to subtract 2.3 from this side and subtract 2.3 from that side. Positive 2.3 and negative 2.3 is just 0, so a comes down. If I subtract this, I'm going to get 9 minus 2, 7.42, it looks like. So 7.42 is our value for the letter A. So my check says A plus 2.3 equals 9.72. So I'm going to replace this A here, and I'm going to put 7.42 instead. Equals 2.3. If you leave it like this, I'm taking the whole point out. I actually want you to go one step further, add these two, and see that it equals 972, which is the value on the other side of the equation. So these two sides must equal each other. Okay, so here again, whether it's decimals or fractions, it really shouldn't matter. C is my variable. I'm adding 4 over 7th, and that somehow is going to give me negative 3/5. Oops. So going backwards, what's the operation I want to do? I want to do minus 4 over 7. Right, so Again, likewise, divide my equation into 2 halves, my left side and my right side. I want to subtract minus 47 on this side. I'm going to do minus 47 on that side. So 4/7 and minus 4/7 becomes 0. C is what I have left over. And then I have negative 3/5, and I don't have a calculator, so I'm actually have to do this manually. That's 35, right? The LCM is 35, so that's going to be 21, it's going to be 20, minus and minus again. That's going to give us negative 41, and I'm going to leave it as an improper fraction. So C equals negative 41 over 35. Over here, I'm going to check. So it's negative 3/5 equals C plus 4/7. Let's see if that's true. So again, this stays, this stays, this stays, and the only thing, I got to remove that C, and instead I'm going to put negative 41 over 35. So somehow I have to make sure that this is equal to negative 3/5. So on the left side, there's nothing to do, but on this right side, I actually have to do, add them up. So I get negative 41 over 35. Plus, I'm going to change that 7 to 35 because that's the LCM. So it's times 5 and times 5 on top. And 4 times 5 is 20. Negative 3/5 on that side. Negative 41 and 20 is negative 21 over 35. And I'm going to simplify this a little bit more just to make sure it equals negative 3/5. 21 divided by 7 is 3. 35 divided by 7 is 5. And look at that. The left side does equal my right side. So that's done. My variable W, 2.5 is being added to it, and that's going to give me negative 6 2/3. Going backwards, I'm going to, so let me put plus. The inverse operation is minus 2.5. So it's minus 2.5 on this side, and I'm going to subtract minus 2.5 on this side. Okay, so these two go away. W comes down, and what's negative 6 2/3 minus 2.5? So if you have a calculator, obviously please use it. I will do this the long way, so that's going to be negative 1820 over 3 minus 5 over 2, right, as an improper fraction. The LCM is 6, so it's 40. This is times 3, it's 15, so that equals to negative 55 over 6. So W equals negative 55 over 6. All right, so now we got to make sure that it is the right answer. So I'm going to prove it. So I get 2.5 plus equals negative 6 2/3. So I'm going to change this to negative 55 over 6. So these two must equal negative 6 2/3. And if you just leave it like this, I can't tell and you can't tell if your answer is correct. So we actually have to do it. So you have a calculator, use it. I don't. I have to do this. So this stays, nothing to do on this side. Negative 6 2/3. And on this side, I'm going to change it 2.5 into 5 over 2. Okay, so I get 5 over 2 plus negative 55 over 6. Let's find the LCM, which is 6, right? So I'm going to change that to 6. And this is times 3, and times 3 on top is 15, and negative 55. 55 plus negative 55, it's going to be 50, negative 50 actually. And, no, 45, what am I doing? Negative, hang on a second, negative 40, I'm sorry, because there's more negatives. Negative 40 over 6 equals negative 6 2/3. Are they equal to each other? Well, let's change this guy here to an improper, or change this to a, mixed. This changes to a mixed number, or change this to an improper. Really up to you. 6 goes into 40 6 times. 36 2/3. There's 4 left over. Right, 6 going to 46 times, there's 4 left over 6. And you're going to say, well, that's not the same. Well, if you simplify 4 6 over here, it becomes 2/3. So now they're exactly the same. Okay, so becomes repetitive after a while, but it's just habit forming now. Right? Here's my variable h plus 4.8 equals 23.5. Then going backwards, what we're going to do, we're going to do minus 4.8. Right? So we need, in this equation, to subtract 4.8 from this side and 4.8 from that side. These two go bye-bye, the h comes down, and 23.5 minus 4.8 is 15.7. 12 minus 4 is, I have no idea, 12 minus 4 is 6, and 16. So h is 16.7. Let's see if that's true. 23.5 equals 4.8 plus h. We're going to replace that h with 16.7, so 4.8 plus 16.7 has to equal 23.5. Plug it in. Let's just add this over here. 15 goes 1, 21.5. No, hang on a second. Something's wrong here. 15 goes 1, 21 goes 2. No, I'm still wrong. Yeah. Wait a second. Oh, stop. What did I do wrong? Well, that's it, because 12, so here's my mistake. So 15 minus 8 is 7, and 12 minus 4 is 8, so h is actually 18.7. So here's an example of why a check is important. I would have lost everything here. So 4.8 plus 18.7, let's see if that actually works now. Decimal under decimal, 7 plus 8 is 15, carry the 1, 22, 12, 13, 41, 23.5. And yes, left side equals right side, so check. Here's my variable b, which I am going to be subtracting 12, and that somehow is going to give me negative 23. The inverse operation is going to be minus 12, which is plus 12. So what do I have here? So again, here's my equation. I'm going to do plus 12 on this side and plus 12 over here. B comes down, and negative 23 plus 12 is negative 11. No, hang on a second. 111, yeah. Negative 11. Let's see if that's true. So I got negative 12 plus b equals negative 23. Negative 12 plus negative 11, right? Because the b is negative 11 equals negative 23. So if I add these two, do I get negative 23? Yes. And that means my left side equals my right side. So again, nothing different, and by now hopefully you are more comfortable. So m is my variable, it's being subtracted. 4 is being subtracted, and that's going to give me negative 5. So the inverse operation of subtracting 4 is adding 4, so let's do that. Let's add 4 to both sides. These two go away, because negative 4 and plus 4 is 0. M comes down, and negative 5 plus 4 is negative 1. Please check. Negative 4, this is my original equation. I'm going to replace the m here, and I'll put negative 1. Minus 4 equals negative 5. Is that really true that negative 1 minus 4 is negative 5? It is. So I can clearly write the negative 5 on the left side is equal to the negative 5 on the right side. So we are good. Likewise, w is my variable, minus 23, and that's giving me negative 34. So going backwards, I'm going to add 23 to both sides. So remember, you're adding the same number to both sides just to keep the balance. Whatever you do to the left, you must do to the right. Okay, so plus 23, plus 23. And these two go away, so w equals, what is that, 11? Negative 11, right? Let's check. Negative 34 equals w blank minus 23. So in place of that w, I'm going to put in the value that we just found, and that's negative 11. So negative 34, and does that equal, are they equal to each other? Yes, it is, because negative 11 minus 23 is negative 34. I don't know if I should do, well, I should. No, I'll do the rest. Just don't want to make the video too long. So again, here we have k k, and it's being 34.2 is being subtracted, and that's going to give us negative 11.4. So going backwards, I'm going to add 34.2 to both sides. So follow your instructions. Plus 34.2, plus 34.2. These two go away because they're opposites. Negative 34.2 plus 34.2 is 0, so I don't. And then a k is left over. And then on that side, I'm going to subtract those. So 34.2, 11.4. You have a calculator. 12 minus 4 is 8. 3 minus 1 is 2. And I get 22.8. So my k, according to my calculation, is 22.8. So that's 11.4 equals minus 34.2. And I'll remove that k and put 22.8. So 11.4 negative is 22.8 minus 34.2, 11.4. Yes, it is. So again, left equals right. My note is correct. Fraction, yay, especially because I don't have a fraction calculator. Variable b, minus 7/8 is equal to negative 4/9. Plus 7/8. So going backwards, I'm going to do plus 7/8. The inverse operation of subtraction is addition, so I'm going to add 7/8 on this side. And I'm going to add 7/8 on that side. These two additive inverse, right? So it gives me a b. And I have to actually do 4/9 plus 7/8. Well, something over 72. So it's going to be 32/63. It's going to be 72, 31 over 72. So let's see if that's true. So again, I have b minus 7/8 equals negative 4/9. So instead of the b, I'm going to replace it with the value that we found, which is 31 over 72. Minus 7/8 equals negative 4/9. So if this guy here does not equal negative 4/9, we're in trouble. So what's the LCM? The LCM, and then I'm going to put 72 here, minus 72. This one's already 72, so leave it alone. So, but the 7/8, the equivalent fraction of 7/8 with the denominator 72 is times 9, so that's 63. So for sure it's going to give me a negative number over 72. And that's going to be 32. And can I simplify 32 over 72 to negative 4/9? What can I divide top and bottom by? I can divide 32 by 8. That gives me 4. And 72 by 8. That gives me 9. And guess what? The simplified version is the same. Well, this is also the same. But just to double check, simplify it and make sure both sides are good. Another fraction. So v is my variable. It's negative 3/4, 3 4/5 is being subtracted, and that's going to give me 1/7. So going backwards, the inverse operation I'm going to do, I'm going to add 3/4 to both sides, 3/5 to both sides. So let's do that. Plus 3 4/5, and then plus 3 4/5 on that side. These two cross out. V comes down. So I have 1/7 plus 3 4/5. I'm going to change 1/7 plus 15, 19 over 5. Okay, so I changed that to improper fraction. LCM is 35. It's going to be a 5. It's going to be a 3, 6, 133. So the total is going to be 138 over 35. And that's my value for V. So I'm going to leave it like that. Now I'm going to do my check. My check is V minus 3 4/5 equals 1 over 7. So my V that I found out was 138 over 35 minus 3 4/5 has to give me 1/7. So find a common denominator. So 138 over 35, not going to change. But this is going to be 3 4/5 is actually 15, 19 over 5. Right? So I'm going to change 19 over 5 to something over 35. So it's times 7, and then times 7 over here. 7 times 9 is 63, goes 6, 133 equals 1 over 7. So let's see. 138 minus 133 is 5, and then over 35 equals 17. Is 5 over 35 simplified equal to 17? Yes, it is, because if I divide top and bottom by 5, I get 17 equals 1,000. So we're good. Variable t minus 23.1 equals negative 9. So going backwards, I would like to do plus 23.1 to both sides. So plus 23.1 plus 23.1. These two cross over, so t equals, and you know what? I'm going to subtract those two, so it's 23.1 minus 9. It's going to give me 14.1 positive. Here's my original equation. 23.1, and that has to give me negative 9. So t, I replace t with the value we found, which is 14.1. So this has to give me 9. So if you do it and I calculate 14.1 minus 23.1, it's going to give us negative 9. Sorry, that was negative. And that's exactly what we want. Last one. P minus 23 equals, so again, here's my variable P minus 23. It's equal to negative 45. Going back here, we're going to get plus 45. So we have to do the inverse operation. Oh, but why did I get no. It's plus 23, sorry. So show that. Plus 23, plus 23. These two go away. P comes down, and negative 45 plus 23, there's more negative, so that's going to give me negative 22. That's my answer. Check. P minus 23 equals negative 45. So negative 22 minus 23 equals negative 45, and these two added does equal negative 45, which equals negative 45 on the other side. So, all right. Answer of P equals negative 2 is correct. So I think there was 3 more problems, right? The ones that most of you finished quite a lot of these. So give me 1 second and I'll try to find it. Pause. All right, so these are the last 3. Okay. So again, over here in the corner, if you can just kind of sneak it in, here's my variable t. Subtract 27, it's giving me 80. Subtract 25 is giving me 87. Going inverse operation, I'm going to do plus 25 to both sides. So let's show the work. So the first thing I want to do is plus 25 here, plus 25 here. Minus 25 and plus 25 go away. T comes down because that's the only thing left over. And 87 plus 25 is 112. So the value of t is 112. Done. Check. So I want to do 87 equals t minus 25. That's my original equation. So wherever I see t, I'm going to replace it with 112. Again, please don't leave this like this. Take the extra step. That's 87. In your calculator, make sure 112 minus 25 is 87, and it is. How did I get here? I use the inverse operation of what? Of subtraction, right? I use the inverse operation of subtraction, which means I added 25 to both sides. Why did I do that? To isolate my variable. Right? So by adding 25 to both sides, look, my variable was all by itself. Okay, so that's what isolate means. Have your variable all by itself, and that's what it does. It did in this case. And that's how I got there. Next one, 24 plus v, and again, here's my v variable. I'm adding 24 to it, and it's giving me a 67. So the opposite of adding 24, the inverse operation would be minus 24. So I need to subtract 24 from both sides. If I subtract 24 from here, I need to subtract 24 from the other side. But subtracting 24 from that allows me to have v. Look, there's nothing else on the left side because the 24s are gone. So v is the only thing I've left on the left side, and that's what I wanted. And then on that side, 67 minus 24 is 43. Let's see if that's correct. My original equation is 24 plus something equals 67, right? And we found out the value of that something. The value of that something is here, it's 43. Is it true? Well, 24 plus 43 is 4 plus 3 is 7, and then 2 and 4 is 67. Look at that. Now you can write all that. Again, in this case, I did the inverse operation of addition, which is subtraction, which means I subtracted 24 from each side. And that got me to isolate my variable, right? My variable got to be all by itself, and I found the value of v, which was 43. Last but not least, w is being currently just 23 subtracted from it, and that gives you negative 42. Going backwards, we need to add 23 to both sides. Right, so let's add 23 here. Let's add 23 here. On this side, 23 and 23, minus 23 and plus 23 go away, and now all I have left over is w. On the right side, left side, negative 42 and 23 is going to give me negative something, so that's going to be negative, negative 19, by the way. So w is negative 19. Don't trust me. Negative 42 equals blank minus 23, and that blank is going to be filled in by this. I just want to change color, so negative 19. Negative 42, and on this one you can put in your calculator or just add it in your head. Negative 19 plus negative 23 is negative 42. So on the right column you can write, I did the inverse operation of subtraction, right? What I did here was the opposite. The inverse of subtraction, which meant I added 23 to both sides, and that got me to eliminate my constant here, and w got to be isolated all by itself. And when I checked, everything was good. All right, so that was it.